All right, we're going to pick up our review of logarithms with talking about review question 6, which is solving this exponential equation. So I have two methods for solving an exponential equation. Method 1 is to try to get both sides of my exponential function to have the same base. So it looks like I might be able to make both sides of this function base 2, except 2 times 2 is 4, and if I multiply it by 2 again, I get 8, and nowhere in there do I get the number 7. So method 1 doesn't actually work, which is fine. We still have method 2. In order to do method 2, I have to take the log of both sides. I have to be able to take this exponent out of the exponent. So I'm going to do the log of the left side, 2 to the x plus 1 power, like that. And I'm going to do the log of the right side as well, the log of 7. Now the reason that's helpful is because I can take this exponent, x plus 1, and move it to the front of my logarithm. X plus 1 comes out, and it will be multiplied by the log of 2 that I have left over. Now if I want to find my final answer, I just have to get this log of 2 away from the x plus 1, divide both sides by the log of 2, and then I'll end up with just x plus 1 equals whatever this number is, log of 7 divided by log of 2. Now after I finish dividing those in the calculator, all I have to do is subtract 1 from both sides to get my final answer. So x is going to equal log of 7 divided by log of 2, which if you type in the calculator is 2.807. And then we subtract 1, and we get 1.807 as our final answer. All right, so let's go ahead and try the next question. Also exponential form. I want to try and solve this guy. Now there's a couple different things I'm going to have to do here, because if you notice, I have this minus 4 and 2 inside this exponential function happening after that exponent happens, which means they're wrapping up my exponential function, and I'm going to want to unwrap it before I do anything else. I want to get this exponential function isolated. So I'm going to add 4 to both sides to undo that step. I get 2 times 3 to the 2t minus 5 equals 15. And then I'm going to divide both sides by 2 to get the exponential function all by itself. So I'll get 3 to the 2t minus 5 power equals 15 over 2, which I can do as 7.5 if I want to, because I can already tell that this is not going to be a very pretty answer. Now the reason for that is because if I try method 1 right now, I could try to give both sides base 3, but as soon as I multiply it by itself, it's 9, and it's not going to equal 7.5. So method 1 doesn't work, which means I'm going to have to take the log of both sides, the log of 3 to the 2t minus 5 power equals the log of 7.5. This is method 2. So the reason method 2 is helpful, it lets us bring that exponent to the front. So we're going to get 2t minus 5 times the log of 3 equals the log of 7.5. Now again, just like the last problem, I can divide both sides by the log of 3, divided by the log of 3. I get 2t minus 5 equals whatever this number is, log of 7.5 divided by log of 3. I'm actually going to type that in the calculator. I get 1.834. And in order to finish solving this problem, I have to get t completely alone. So what I'm going to have to do is add 5 to both sides, plus 5 plus 5. So 2t is going to be equal to 6.834, and then I'm going to have to divide both sides by 2. Now you can type that all in the calculator in one fell swoop if you would like to. Our final answer, t, is going to be 3.417 right there. As long as we're rounding to 3 decimal places, we're going to be okay with that answer. Okay. I only have a couple more to try and solve. Let's go ahead and take a peek at question 8. We're going to try and solve this logarithmic equation. Log base 3 of 2x minus 1 equals log base 3 of x plus 4. This is the easiest type of log to solve, because if the log of this number exactly equals the log 3 of this number, that means those two numbers are actually going to be equal to each other. So we don't actually need the log base 3 at all. So all I have here is 2x minus 1 equals x plus 4. Now all I've got to do is subtract x from both sides to get it all in one spot. So x minus 1 equals 4, and then we add 1 to both sides here. So x equals 5. So if you have the same log base on both sides, you can cancel it out. You actually don't need that bits at all. Those bits. All right. Couple more to take a look at on the review. Let's try number 9. We'd like to solve this logarithmic equation. Now, in order to solve a log function, I do need to make sure that my log is in just one spot, isolated and condensed. So in this equation, I have log in 2 different places, which means I'm going to want to smush those together into one giant log using my log properties. So I can write these inside one giant log. It will have the same base as the original. And all I have to do is mix up the insides. They're being added together, so they're both going to go to the numerator. They're going to be multiplied together. 3 times x. And that's going to be equal to 4. Now that I have this log smushed together, and there's nothing else happening on the left-hand side except for the logarithm, now I can undo that log by rewriting it using a log roll. So we're going to do 2 to the 4th power equals 3x. All I have to do now is figure out what 2 to the 4th is. It's 2 times 2, which is 4, times another 2 times 2, which is another 4, so it's 16 equals 3x. And then we can finish solving for x by dividing both sides by 3. So x is going to be 16 over 3, which is a fraction, and that's fine. It is an exact value, and that's how I'd like us to leave our answer. Right, we just have one more solving problem to try on this review packet. This one is a little bit more challenging, but it's not something impossible to do. We're going to start it the same way we started the last problem. I have log in 2 different places. I'm going to smush them together into one giant log. So we have the log of 5x times x minus 1. So there's our logarithm. So both of these were being added together, so I multiplied them inside my giant log. And I can actually multiply those together. So I'm going to distribute my 5x inside this log. So we get the log of 5x squared minus 5x once I distribute that guy together. Now I have my log in just one spot. It's isolated, so I can get the x's out of my logarithm by doing a log roll. So I start with my base, which is this invisible 10 right here, and I raise it to the 2nd power, 10 squared, and it's going to be equal to the number inside my logarithm, which is this 5x squared minus 5x. Now I do know what 10 squared is. It equals 100. And if I want to solve this, since we have this x squared and this x, and x is in more than one spot and it's not to the lowest power possible, I am going to have to factor before I can solve. And the only way that factoring is helpful is if my equation's equal to 0, so I can use the zero product property. So I'm going to subtract this 100 from both sides to get everything all on one side. I end up with 0 equals 5x squared minus 5x minus 100. And now I can start the factoring process. So we're going to do the first step of factoring, which is GCF, and my GCF is 5. So I'm going to do 0 equals 5 times x squared minus x minus 20. So I factored 5 out of everything. And now I have to factor what's left inside this quadratic. So I can use a t-chart, 2 things that multiply to negative 20, that add to negative 1. Those numbers are going to be 5 and 4, and the 4 is going to be the one that's negative. So here, I can do x minus 5 and x plus 4. Now to find my final solutions, I'm going to have to set each term equal to 0. I can start with 5, but 5 will never equal 0, so that won't give me an answer. I can then do x minus 5, which would mean that x would be the number 5, and I can do x plus 4, so x would be negative 4. Now these 2 could be my possible solutions, except that we're not allowed to plug a negative into a log. So negatives, no negatives in a log. So if I go back to my original logarithm, if I plug in negative 4, here, this would be negative 20, which is not allowed. And same thing over here, this would be negative 5, which is not allowed. So I'm not actually allowed to use the number negative 4 at all. But if I plug in 5, all of my values are fine, which means x equals 5 would be my final solution there. X equals negative 4 would actually be what we call extraneous, because it solves one piece of my equation without actually solving the original. That's it for the review. Please let me know if you have any questions. Good luck studying.